Hello, everyone. I'm Lori Torrini with Behavior Education at Spirit Keeper Animal Sanctuary. I'm also a graduate student at Unity Environmental University, and I'm presenting the findings from my capstone project, Maternal Care of Neonates by a captive amethystine python, Simalia amethystina. This project, focusing on the maternal behaviors of snakes, addresses something that remains largely unexplored in herpetological research. My collaborators and co-authors, Claude Gagnon, Paul Duren, Crump, and Dr. Emily Kieson, were invaluable throughout this study. Let's take a look at the significance of this study and its findings. Traditionally, snakes have been viewed as solitary animals with minimal parental investment. However, emerging research like the 2018 study by Dr. Alexander, which documented maternal care behaviors in Python natalensis, challenged this assumption. We selected Simalia amethystina, another python species, due to a gravid female housed under pseudo-naturalistic conditions being available to observe for our study. The goal of this project was to determine if this species engaged in maternal care and then to observe and document these behaviors in a controlled setting. This study matters because it challenges the long-standing notion that snakes exhibit minimal to no maternal care. By documenting these behaviors, our goal was to fill gaps in herpetological knowledge, inform species-specific welfare practices, and progress best practices for conservation breeding programs. Our objectives were first, to document maternal behaviors post-hatching, and second, to analyze trends in these behaviors to better understand their possible significance. This study was conducted in a controlled environment designed to minimize interference, ensuring observations were as authentic as possible. We used continuous video surveillance and developed an ethogram to categorize and analyze maternal behaviors. This was a collaborative effort. As the project lead, I was responsible for the study design, the behavioral observations, ethogram development, communication with the university, and the manuscript preparation. My collaborators helped with behavioral observations and provided expertise in analyzing the videos, statistical analysis, background research, and in refining the manuscript. Now I'd like to introduce you to one of my co-authors, Mr. Paul Duren, who's going to discuss with you who our study subject was and how he went about setting up her habitat and the nest.
Hi, I'm Paul Duren in Seattle, Washington. Our study subject was Bobby, a 7-year-old female Simalia amethystina, also known as the Amethystine Python or scrub python, a non-venomous constrictor native to New Guinea, Australia, and parts of the Indonesian Archipelago. These regions are characterized by tropical forests with warm, humid climates. Bobby was 3.1 meters long and weighed 3.8 kilograms at the start of the study. Bobby and her mate were housed in a pair of large connected enclosures, allowing them access to each other. The habitat replicated their natural environment with daytime temperatures between 25 and 32 Celsius and a nighttime drop to 25 Celsius. Humidity was maintained by an automated misting system. Scrub pythons are semi-arboreal, so the enclosures provided basking shelves, hides, branches for perching, and live plants. Bobby's nest box provided a secure and controlled environment for incubation and maternal care. It consisted of a 17-liter opaque blacks PVC tub with a second hide zip tied above. This setup allowed us to regulate heat and humidity more precisely than in the larger enclosure, with heat at 28 to 31 Celsius and humidity averaging 78%. The interior was filled 2/3 with dry sphagnum moss, which Bobby shaped to suit her needs. Temperature and humidity were monitored using a sensor placed within the moss.
This is Bobby's custom designed nest box, providing a secure environment for her during incubation and maternal care. The main compartment housed the eggs, the middle compartment allowed her to maintain contact with the clutch while monitoring her surroundings, and the top served as an exterior ledge. The full setup remained in the habitat throughout incubation, hatching, and post-hatching care. Bobby did leave the nest to bask, eat, and drink, but always returned to her clutch.
To monitor maternal behaviors, we used a video camera with night vision capabilities. This camera provided high-definition recording and was positioned to capture interactions between Bobby and her hatchlings. The camera operated continuously, ensuring reliable data collection throughout the study. Now Lori will continue by discussing our ethogram.
Behavioral observations were categorized using a detailed ethogram, which served as a standardized tool for analyzing the mother's actions. Each behavior was assigned a specific label and operational definition to ensure consistent recording across observations and by each observer. To train the observers effectively, we did include lay descriptions of each behavior, making the process accessible and reducing variability in data collection. This methodology enabled us to quantify maternal behaviors with precision and clarity. Now we're going to take a look at some preliminary data that was collected during the study. It spans 3 days of continuous observation. We recorded over 3,100 maternal behaviors, and these were categorized into distinct types to analyze patterns and trends across the observation period. The data highlights variations in maternal activity and emphasizes specific behaviors that peaked during different phases of the study. We categorized 10 distinct maternal care behaviors, which you can see in this table here. Over the 70-hour period between when the hatchlings started pipping from the eggs and when they dispersed from the nest, lifting and arching away from the hatchlings while still keeping them contained within her coils accounted for 51.2% of all the recorded behaviors, while the other 9 behaviors made up 48.8% of mom's activity towards the hatchlings during this time. On day 1, we observed 769 maternal behaviors over a 22-hour period, which was the time from when the babies started pipping to midnight this first day. Lifting and arching away from the hatchlings was the most frequent behavior we saw from mom. It occurred 559 times. And other behaviors like body slamming were recorded 65 times. And some of the other behaviors, coiling around the babies and loosening coils, occurred less frequently. Now, day 2 was definitely the most active day for the mom and babies. We recorded 1,354 total maternal behaviors over that 24 hours. Body slamming peaked during this period. It occurred 240 times, and lifting or arching away reached 825 instances. This high activity level by mom coincided with increased hatchling movement, and we think it reflects the mother's adaptive strategies to manage the babies. By day 3, maternal activity significantly declined. We saw 420 behaviors over that 24 hours. Lifting and arching away remained the most frequent behavior, though it was at reduced levels. And body slamming also decreased. There was a shift in mom's interaction patterns as neonates seemed to become bolder, more independent, and ultimately they began leaving the nest on this day. This chart compares the occurrence of each behavior to itself across the 3 days. As you can see, lifting or arching away was consistently the most frequent behavior, and it peaked on day 2 before ultimately declining on day 3, and body slamming followed a similar trend. Okay, so this final trends chart summarizes the overall pattern of maternal behaviors across the 70-hour observation period, which remember was from the time the hatchling started to pip until the last one had left the nest and mom had left the nest. Activity peaked on day 2 with 1,354 behaviors recorded before it declined sharply to 420 behaviors on day 3. These trends reflect the dynamic nature of maternal care. She appeared to be balancing protective and facilitative actions to support the neonate's gradual transition to independence. Maternal behaviors in Simalia amethystina appear to be adaptive, balancing the need to protect neonates while at the same time helping the hatchlings to build resilience as they grow, gain confidence, and gradually transition to independence and disperse. This challenges traditional views of parental investment in snakes. From a practical perspective, these results demonstrate the importance of species-specific management practices in captivity to support optimal well-being, including providing secure, naturalistic, low-stress environments that allow snakes to engage in natural reproduction, incubation, and parental care. The findings also hold potential implications for conservation efforts, particularly in creating successful captive breeding programs for endangered species. One of the strengths of this project was the innovative low interference methodology, which allowed us to capture authentic behaviors as much as was possible under captive conditions. Collaboration and a structured timeline also contributed to our project's success. Limitations included the single subject design and the controlled environment, which obviously cannot fully replicate natural conditions. One of the key lessons learned was that we needed to construct a habitat that would safely contain the hatchlings following their dispersal from the nest, as we had a few escape once they were in the habitat at large. This study lays the groundwork for future research, expanding the sample size to include multiple subjects, and observations of wild populations would provide a broader understanding of maternal behaviors in snakes. Observing the mother and hatchlings following nest dispersal to determine if interactions end at that time or if they continue to interact with each other would further our knowledge of python's social behavior even more. And investigating the ecological and evolutionary drivers of these behaviors could further inform conservation and welfare practices. This research also has potential applications in designing captive breeding programs for other snake species. This research adds to our understanding of the complexity of maternal care in Simalia amethystina. It challenges traditional assumptions and it provides valuable insights for both herpetology and captive management practices. I'd like to thank my collaborators and Unity Environmental University for their support. I want to thank you for your attention, and I'm happy to answer any questions or discuss the study further. I can be reached via email at behavioreducationllc@gmail.com or at ltorrini20@unity.edu. And please remember to always be kind and love your animals.